Hey guys, I'm Avish. This is the 29th video of .NET MAUI with Syncfusion control series. In the previous session, we discussed about the radial gauge control and understood the axis, pointers, range and annotation features of radial gauge control. We have also added interactions to the radial gauge control. Please review the previous session before proceeding. In this session, we will focus on creating a working clock using the radial gauge controls. We will create the hour, minute and seconds needles using pointer property of radial gauge control. We'll also add timer code to keep the seconds timer ticking. We will also enhance the aesthetics of the clock using range customizations. At the end of the session, we will add the multifunctional features using the annotation customizations. Let's now switch to the coding session and get going. I'll be using the same solution file that we have been using from the previous sessions. In the previous session, we have focused on axis, pointers, interactions, and we have defined the customization and styles to all of these radial gauge chats or the controls. In this session, let's now focus on creating a clock. When I say clock, it is a working clock example and how we can leverage on the radial gauge and convert the radial gauge into a completely working analog clock. Let me show you how to do that. Right click on the view model. Let's add a new item and call it as radial chats view model.cs. Let me define this as a binding context for the front end. Once I create this, let's change this from internal to public and then let's have a constructor inside and we will leave it as empty for now. And then I'm going to create few properties called properties and I'll call this as double. I'll explain you why I'm calling this as double and I'll define few properties which are hour and minute. Let me create another double property and call it as minute. That's all. I'm going to extend this class in some time by inheriting the iNotify property changed event so that the clock will tick based on the changed number of seconds, minutes and hours. Before that, right now we have the structure of radial chats view model. Let me switch back to the radial gauge and start creating a new radial gauge chat. Let me collapse all of these things. Let me create a box view on top of this. I want to create the clock on top of the current control. So I've created a line separator and before the line separator I'm going to add a clock on top of it. So let me start with the structure right after the vertical stack layout. Let me now stop the application, switch to Syncfusion and let me drag and drop the SF radial gauge. Now it has created a radial gauge, so let's extend this now. I'll give a name called xname and call it as radial clock. Let me give a height request of 600 and then within the radial axis I'm going to give the end angle equal to 270 and I'm going to give the interval as 1. Minimum would be from 0 and then the maximum would be 12. Since the clock starts from 0 to 12. Then after that, I'm going to give the minor ticks per interval as 4. That's between each and every 5 minutes. I want to give the minor tick interval as 4. And then we will create an offset unit as factor. I'll explain you why I have done this. And then we will have the tick offset starting from 0.03. Let's say 0.03. Once this is done, we will also add a label offset 0.03. Then that's it. Let's run the application and notice the output. Notice that the clock is not complete. That's because I have given the end angle and I have not mentioned the start angle. So let me mention the start angle from 270. Save it, switch back. Now you see that we have a complete clock and you see that there is 0 and 12 getting overlapped over here. We're going to correct that with customizations. However, between each of the 5 minutes we'll have 4 ticks, minor ticks, and then we have the clock starting from 12 and ending to 12. So let's add more customizations to this clock. Let me switch back and add the axis line style within the radial axis. So I would say let's add some colors to this clock. Let's say gauge radial axis dot axis line style. So within the axis line style I'm going to say gauge colon radial line style, and within the radial line style let's fill something called brown color for the radial line style and I'm going to give the thickness as 0.01. Let's keep it very thin, hence the thickness is very less here, and after this I'm going to give the thickness unit as factor and close this radial line style. Let me switch back and show you the clock. It has got a radial line style over here. I can also reduce the height request from 600 to 500 so that it looks a bit elegant. After this, we're going to add the label style as well. Let me show you how to do that. Right after this axis line style, I'm going to give gauge colon radial axis dot axis label style, and within the label style we are going to give the gauge label style as font size as 10, our regular font size, and then I'm going to give the text color as, let me give dark magenta, and let me close this one and let's see the output here. Now we have the label style as magenta. Let me add few more customizations to the major tick style. Let me add the gauge radial axis and then dot major tick style. Within the major tick style, I'm going to add the radial tick style. So I would say gauge radial tick style length is 0.1, 0.1, and length unit will be the factor. Similarly, let me add the minor tick style. So let me copy and paste this major tick style and add the minor tick style here. Minor tick style. In the minor tick style, I'm going to change the length to 0.06 and keep the length unit as factor. Now let me switch back and show you the output. Notice that we now have the ticks which are extended. Now this is representing the clock, but we don't have the hour, minute and second needles. So we're going to create some pointers, 3 pointers, one for hour, one for minute and one for second. So let me switch back to the code and start creating the pointers. Let me switch back and start adding the pointers here. Gauge radial axis dot pointers. So we need 3 pointers, one for hour, one for minute and the other for seconds. So let me start creating an hour pointer, gauge colon needle pointer, and within that I'm going to define knob radius as 0, and then I'm going to add needle end width as 5, and then I'm going to add needle fill and other properties. Let me define the needle fill as violet, needle length as 0.5, and I'm going to add needle start width equal to 2, and then let's bind the value for needle as 1 or 2 for now, but this value need to be changed dynamically based on the user's time. So let me close this needle, save this and switch back, and notice that we now have the needle which is the hour needle. So let me name this as hour needle to distinguish between different needles. So I will call this as x name equal to hour pointer. Now let me add the minute pointer as well as seconds pointer. The minute pointer will be similar to the hour pointer except the width and color. So let me copy and paste it and change this as minute pointer, and I'm going to add the knob radius over here as 0.05, change the width n to 3, and then instead of violet let me choose a different color and call it as blue violet, and then I'm going to add the needle width as 0.8 and the needle start width from 1. Let's change the value instead of 2 to 4 so that we can distinguish between hour and minute pointer. So let me switch back and show you that. Look at that, the hour pointer is much shorter than the minute pointer, whereas the minute pointer is on value 4, hour pointer is on value 2. We need to add a seconds pointer now. So right after this needle pointer, we would say gauge needle pointer and add x name of, and let me name it as seconds pointer, and within this I'm going to add the same properties, knob fill and other stuff till needle start and end lengths. Right after this I'm going to add tail fill, tail length and tail width as well to distinguish the seconds pointer. So let me copy and paste it from my other window. I'm giving the tail fill as green to distinguish, needle fill as complete blue, knob fill will be white. Now let's switch back and see if this is there. Notice that we now have the tail fill as green, and within the knob fill it is complete white, and the tail length is 0.15 with tail fill color as green and the needle fill is blue. We can change these colors based on the requirement, but for now to distinguish I have given these different colors for each of these needles. Now the next step is to give life to this clock by making this seconds pointer ticking. Once the second pointer ticks and completes a rotation or cycle, we are going to change the minute pointer. Let's see how we can achieve that using our view model. Let me switch back to the code and stop the application. Let's now change this radial charts view model to make the clock dynamic. Let me add a couple of properties here, hour and minute. So what I'm going to do is I'm going to get return hour. Similarly, I'm going to do that for minutes so that we can set the hours and minutes based on the current date time. So I'm going to change this as minute and remove this extra stuff, and during the set we are going to set our equal to value. Now setting the value is not sufficient. What we need to do is we need to bubble up the events for the property change. Whenever the property of hour and minute changes, it has to notify the XAML file that the hour has been changed. In order to do that, we need to inherit the iNotify property changed event. So let me add that iNotify property changed event, and whenever we add that, we have to define a public event for the iNotify property changed. Once this is done, whenever the property of the hour or minute is changed, we need to bubble up by adding a method which we have done in our earlier session. So I'll copy and paste the event which is on property change, which will invoke the changed event method. So whenever the property is changed for the hour or minute, I'm going to notify on property changed event by passing the hour value. We will ask the XAML to refresh the hour value and we will notify the XAML file. So once this is done within the minute, we are going to do the same. However, it's going to change from hour to minute. So let me do the necessary changes in the minute as well. So I'm going to copy and paste the same thing here and say minute equal to value, and then on property change we are notifying the XAML with minute. Now this is done. Within the constructor, we are going to assign the hour and minute value. I would say var date equal to datetime dot now, and then we are going to give hour equal to date dot hour and minute equal to date dot minute. But we have the access from 0 to 12, so we are going to do some changes to incorporate the hour. So let's say if date dot hour is greater than 12, then I would say date dot hour minus 12, so that it won't be within the 24-hour interval. Otherwise, I would say date dot hour. Sorry about that. That's it. This is the change which we are going to do. Now we have the ticks between the minutes. I'll show you in a moment how to change that as well. Let's now run this application and notice the output. Notice that the value of minute and hour has not changed. That's because we are not binding the value. So let me switch back to the Radial Gauge, and within the Radial Gauge.xaml file, I'm going to add the binding context. So in order to add the binding context, we need to define the binding context. So I'm going to define the binding here, which is our view model. So right after the radial clock, I'm going to create binding context, and within this binding context, we will add the binding. So let me close this first and say binding colon radial chats view model, and I would say X name. Let me define a name, and I'll let you know why I'm doing it in a moment. I will call this as radial view model. Let me close this application, close this radial chat view model. Now within the hour, I'm going to bind the value as binding hour, and then I'm going to bind this value as minute value minute. Let me restart the application and notice the output. Look at that, the hour and minute are to the current date and time values. However, I see the seconds pointer not working. In order to make it work, we need to add the X name as the seconds pointer, which we have done that, and we need to start ticking the seconds pointer. Let me show you how to do that. Let me switch back to the radialgauge.xaml C# file, and within that, let me add a couple of properties called seconds and stop timer. And then I'm going to create a private method called start the clock. And in this method, we are going to add the current seconds and delay. So we are starting the seconds from 0, and if application.current is not null, I'm going to start something called update seconds method. So let me create one more method called update seconds, and within this update seconds, if the timer is stopped, we are going to return it as false. Otherwise, we are going to return it as true. Let me add those two properties, and let me fill the other properties later. And then I'm going to add within the start clock, if the application.current is not null, I'm going to start the timer a span of every second within the time span, and I'm going to call update seconds method, and then I'm going to say stop timer is false. Now whenever it invokes the update seconds, we are going to increment the seconds by 0.2 factor, and then we're going to increment the seconds timer, which is our seconds pointer. So we are going to say this dot, if the seconds is greater than 12, then we are going to reset it. Otherwise we're going to say else this dot seconds pointer dot value is nothing but our seconds which is ticking above, which is what ticks every 0.2. The reason I'm putting 0.2 is we have for every 5 iterations we have this progress to 1 tick. We will have 5 minor ticks. 5 into 0.2 is 1. That's the reason we are starting with 0.2. Now within this, once seconds pointer completes one circulation, we are going to reset the seconds to 0, and then we're going to re-increment the seconds again, and we are going to reassign the value to this seconds so that it bubbles up the event. Notice that this seconds pointer is binded not to the view model but directly to the C# file. Now let me start the application and show you the output. Before that, let me invoke this start clock right after the initialize component so that it starts ticking the value. I can also add one more called stop clock, which we can use it as and when needed. We can add a button on the clock and say stop clock, and this gets invoked. But for now, I'm going to add the stop clock and stop timer equal to true. Now let's restart the application and see if it is changing the value. Notice that the second pointer is now ticking. However, my hour and minute pointer are at 12. The current time in my location is 12:47 p.m. In order to adjust the minute pointer, we need to do some changes over here. So let me switch back to the model, and wherever I'm assigning the minute, let me do some changes for the minute and hour. So right after assigning 12, I'm going to do some changes to the hour, which is date.minute by 60. So I'm dividing it by a complete cycle of 60 minutes and then computing the hour pointer. Let me do the same thing for the minute pointer as well. Instead of adding date.minute, I'll comment this code and add this code which says date.minute slash 60 into 12. Now let me restart the application and show you the output. Now we have the second pointer ticking and the minute pointer here. Whenever the second pointer increases or completes one cycle, we need to increment the minute pointer. We can do that in multiple ways. So the first way is to, whenever we are updating the seconds over here, we can say if it is greater than 12, we can say this dot, seconds radial. Now you have access to the radial view model dot minute. We can assign the minute, or we can invoke a method in the radial view model and increment the minute as well. I'm going to reassign the minute pointer by calling a method in the view model. Let me now move this code to a common method called public void update time, and within this method I'm going to move this entire code into this method. Once that is done, I'm going to call this and invoke this method. I'm going to do the same in the XAML file as well. Whenever the second increases to 12, whenever we are resetting the seconds, I'm going to invoke this dot radial view model dot update time. That's it. So it's going to invoke the time, and once 1 minute is completed, it's going to increment the minute. Let me restart the application and show you the output. Notice that my current time is 12:50. Once the second pointer completes one cycle, you will notice that the minute is incremented. Now that we are done with the minute, hour and seconds pointer and with the dynamic clock or watch, we can enhance this by adding multifunctional watches within this watch. We can create different country related watches or hour or minute handle within this watch. We can leverage on the annotations and enhance this to add more multifunctionalities. Let me show you how to do that. Right after the pointers, we can create the annotation. Let me copy and paste from my other window to make it faster. And then within the annotations, I'm going to create a gauge annotation, and within that gauge annotation, I'm going to add a content, gauge content, and create another analog watch within that. So within the gauge content, let me close this gauge content, as well as let me close this annotation as well. And notice that I have a direction value which is 9.5 and position factor at 4 with an axis value, which means whenever I'm going to create another axis within the gauge content, this axis is going to represent at 9.5 of the number. So I'm going to add a radial axis and a radial gauge within this content. Let me close the grid as well. Now, similar to the outer gauge, I have created another gauge annotation content with a grid and a radial gauge within that content. So let me restart the application and show you the output. Look at that. At 9.5, which is in between 9 and 10, I have created one more multifunctional clock. Similarly, I can copy and paste this, and I just need to change the direction value. Let's say I'm going to add this between 2 and 3. So I would say 2.5, and then let's say we want to add one more at 6. We can do that by adding the axis and factor. So let me copy and paste this and change it as 6. Now let me restart the application and show you the multifunctional watch. Look at that. We now have 3 multifunctional watches. And of course, we have 0 and 12 being overlapped here. So let me correct that. I would say show first label as false. Let me switch back. Now you have 1 to 12. Now I'll leave you guys to enhance these multifunctional watches within this watch. And I'll now focus on the adding a radial range. Now, in order to make this clock aesthetically look good, I will utilize the customization of range. So in order to do that, I'm going to add ranges within the axis right after the annotations, and within the ranges, I'm going to mention a range gauge, radial range, and within the radial range, I can mention the end value, which is 12, and start value, which is 1, and I can add a fill. Let's say I'll add a fill as light pink, and then I'm going to add a width unit equal to factor, and then we will have start width, which is 0 to start off, and then we can have the end width, which is equal to 0.1. Now let me switch back and show you the range. Aesthetically, the range is not looking good, so let me add some more customization to make it look better. So let me split into 4 quarters with the start and end value, and I will add a couple of more radial ranges to make it look good. So I've added one more radial range, which starts, the first one starts at 1 and ends at 3, the second one starts at 3 and ends at 6, likewise 6 to 9 and 9 to 12. Now let me switch back and show you the output. Look at that, it is looking more aesthetically good. Now you can reduce the start value and end value, or you can have the same start and end value so that you don't get any deviation of the width from starting to ending. It's up to you how you customize the values, but however, I would like to make a point that we can utilize the radial ranges to make it look more aesthetically look good. With this, we have successfully completed the radial gauge control. In the next session, we will focus on the linear gauge control. Till then, thank you for listening and have a great day.